Hello everyone, how are you? My name is Prakhar Shrivastava and I welcome you to TechnoGATE, where we are going to discuss today a new chapter, that is a chapter on matrix and determinants. See, whenever it comes to matrix and determinants, first you need to understand why you need to study this, how you need to study this, what are the different parts, or what are the different chapters that you need to study in this, what are the important areas that you need to discuss so that you will be able to solve 100% of the questions. And believe me, this is a chapter which we are going to cover in 5 lectures. And this is going to be a very easy session for you for the next 5 classes, because matrix is one of the easiest chapters that are there. So I'll first brief you about what is matrix and how you need to study it and why you need to study it. See, everything is made up of data these days, but the best possible way to store a data is in a matrix form. Either you will store a data like this, or you will store a data like this, that is some columns and some rows, right? Or you will store a data like this, some column, some rows and some 3D areas, right? So you will form a data in form of a cube. Suppose there is a cube 2 by 2 by 2. So 2 by 2 by 2 will be having 8 1 by 1 by 1 blocks. Each blocks contains a data. So you can store data. That is why the upcoming area, that is the engineering field, consists of data-driven approaches. And to understand those data-driven approaches, you need to understand how you extract a data or how you store a data. So that is why you need to understand the matrix part. And a specific case of matrix comes as a determinant. Whenever the matrix is, see, I'll tell you very simple thing. After these 4-5 sessions, you will be able to solve almost all questions related to matrix. But first, understand, a matrix, most of you are aware about, have some values arranged in column and rows. Have some values arranged in column and rows. Okay, so let us say that this is m cross n. That is, m represents the number of rows and n represents the number of columns. Okay. When m becomes equal to n, that is number of row and number of column are same, we call this a square matrix, right? Simple, sir, very simple thing. We will call this a square matrix. Like this is a square matrix because there are 4 rows and 4 columns. Now, whenever there is a square matrix, you need to understand this thing. That in that case, we are also able to calculate the determinant. So I will tell you about the matrix. I will tell you about the determinant. What are the different kinds of questions that can be formed from determinant? Previous year question that have been asked from this topic. Everything we will be discussing in upcoming 5 lectures. Okay. So matrix you understood. Basics of matrix you understood, that it is used to store data. Okay, and a special kind of matrix is called a determinant, where the number of rows and the number of columns are equal. For gate, you only have 2D matrices, that is m cross n. You don't have m cross n cross p, that is a 3-dimensional matrix. No, you are only having a matrix which is having rows and columns. Now, according to you, the data is stored in form of a matrix in rows and columns. Okay, in rows and columns, and in these rows and columns you apply different operation to get the desired results. Okay, and a special case of rows and column is when the rows become equal to column. That is known as square matrix, and for square matrix we can go a step ahead and calculate the determinant. So today we are going to start with the determinant, and I would request, please be attentive, because there are very small things that you need to know to calculate various things. Okay. Okay. So I will start with the determinants. See, I will tell you about the determinant first. See, we'll start with the smallest matrix for which determinant can be calculated. Sir, smallest matrix for which determinant can be calculated should be 1 cross 1. So the determinant, suppose this is a matrix, so the determinant is A only. Okay, and determinant is not written like this. Square and closed brackets are used for matrix. To calculate a determinant, you write the straight values 1 cross 1. Suppose for 2 cross 2, what will be the value of determinant? Very simple, sir. A will be multiplied to D minus B will be multiplied to C. Okay, sir. Fine. Suppose it is three-dimensional. A, B, C, D, E, F, G, H, I. This is a 3 cross 3 determinant. How will you calculate this? I will tell you. Sir, it can be calculated in form of 2 by 2 matrix, because there are many 2 by 2 matrix that are clearly visible. Yes, obviously you can write it. I'll also say yes, you can use it as 2 by 2 matrix. You can use it as 2 by 2 matrix. That is not a very big deal. Yes, you can use it. I will say, yeah, you can use it. Not a very big deal. So that is why, sorry. So this is something that you don't know, and now I will teach you how to calculate it. So the first, you need to write that each value in a determinant is known as element. E-L-E-M-E-N-T. E-L-E-M-E-N-T. Okay. Now, very simple thing. Second thing, you have to learn about cofactors. So please give a heading, cofactors. Sir, what do you mean by cofactor? Sir, what do you mean by cofactor? Sir, what do you mean by cofactor? I'll tell you. See, please understand. A, B, C, D, E, F, G, H, I. Now, this is a position that is represented by first column and first row, right? I will write for any position which is represented by I comma j. How you calculate a cofactor? You take minus 1 to the power I plus j. Okay, and you take the determinant of the remaining value. For example, here minus 1 for, देखो, you need to calculate cofactor for each position. This is a position. This is a position. ठीक है? This is a position. 1 comma 1 position. So C1 comma, see, this is very important because this will be helpful in inverse as well. So you have to be attentive. You have to be attentive. C1 comma 1 is minus 1 to the power 1 plus 1, that is I plus j, into determinant of. Now this row and this column will be eliminated, and now you are left with which thing? These four things. Okay, because this row and this column is eliminated. E F H I, E F H I, and now you know minus 1 to the power 2 will be 1, and this is a 2 by 2 determinant that you know how to calculate. That is EI minus FH. FH. Okay, sir. The cofactor for this position you have calculated. Okay. Now, let us calculate the cofactor for this position. That is C of. This is row 1 but column 2. Row number 1 but column number 2. So for this position, how you will calculate the cofactor? That is minus 1 to the power 1 plus 2. Minus 1 to the power 1 plus 2. And you take the determinant of the remaining thing. That is first row and second column is eliminated. You are left with these values. That is DFGI. DFGI. And this will be See, minus 1 to the power 3 will be minus. And what will be the determinant? Di minus Gf, or rather Gf minus Di. This will be the cofactor, not determinant, sorry. This is determinant we are calculating for 2 by 2. Now you understood how to calculate cofactor for each position. I will solve one question where you need to calculate cofactor for each position. But I hope you understood how to calculate cofactor for each position. How to calculate cofactor for each position. Now, please write the cofactor for any element in a determinant. The cofactor for any element in a determinant is obtained by deleting the row and the column which intersect in that element. The row and the column which intersect in that element with a proper sign. Sign kaise? How you calculate sign? Minus 1 to the power I plus j, right? I don't think that you should be having any doubt. Now you have to understand the third thing. See, you understood what do you mean by 2 by 2 matrix and 1 by 1 matrix. Now second thing you understood is how to calculate cofactor for each position. Cofactor is not for a matrix. Cofactor is for each position. For each position you have calculated a cofactor. Okay. And now third thing is Laplace expansion. Third heading is Laplace expansion. Okay. I'll tell you what do you mean by Laplace expansion. Laplace expansion. It states that A, B, C, D, E, F, G, H, I. Okay. You say this one thing. Laplace says the determinant is equal to, that is the determinant of this matrix will be equal to sum of cofactor of any row or column. That is cofactor of any row, that is C11 plus C12 plus C13. This is equal to determinant C21 plus C22 plus C23. That is sum of cofactors of any one row or any one column, or it can be equal to C31, that is cofactor of this plus this plus this, that is C32 plus C33, or sorry, okay, now it can be equal to sum of cofactor of any column as well, that is C11 plus C21 plus C22, that is cofactor of this plus cofactor of this plus cofactor of this. So this is what do you mean by Laplace expansion. This is what do you mean by Laplace expansion. So please write it down. Now you know how to calculate determinant of a three-dimensional body, 3 cross 3 body. So 3 cross 3 determinant is calculated as sum of cofactors. Sum of cofactor of any row or any column. Sum of cofactors of any row or any column. Okay. So for example, it will be equal to, what will be the cofactor of this position? It will be equal to minus 1 to the power 1 plus 1 into EI minus HF multiplied by this element, that is A, okay, plus second element B. Okay, sorry, this is, see, it is equal to, I wrote wrong in the previous, you can write it. This is what? This is A11, that is element 11. Element 11 into cofactor 11 plus element 12 cofactor of 1 2 plus element 1 3 cofactor of 1 3. This is what you mean by determinant. That is, it is not sum of the cofactors, it is sum of the multiplication of the element and its cofactor. It is sum of multiplication of element and its cofactor for any row or any column. Okay, okay. Now B into minus 1 to the power first row second column, first row second column, and it will be di minus gf plus c into minus 1 to the power 1 plus 3, that is first column and the first row and the third column. So this row and this column will get eliminated, dh minus ge. This is how you calculate a determinant. Now you can calculate it along any row or any column. You are not restricted by that. You can calculate it along any row and any column. You are not restricted by that. Okay, but you just have to know that what is the value of determinant. It is equal to, in a row it is equal to in a row or a column it is equal to summation of the multiplication of the element and its cofactor. Okay, the multiplication of the element and its cofactor. Okay, I'll tell you the official definition. A determinant can be expanded in term of any row or column by multiplying each element of the row or column in terms of which we intend expanding the determinant by its cofactor, and then add up all these terms. Very simple thing. See, for any matrix, now suppose this is a matrix A B C D E F G H I J K L M N O P. Now how you calculate the determinant? Very simple thing. Very simple thing. A into cofactor of 1 comma 1 plus B into cofactor of 1 comma 2 plus C into cofactor of 1 comma 3 plus D into cofactor of 1 comma 4. Simple, very simple. You can expand it along this as well. That is I into cofactor of 3 comma 1 plus J into cofactor of 3 comma 2 plus K cofactor of 3 comma 3 plus L cofactor of 3 comma 4. Anything, all these things are valid. All of these things are valid. All of these things are valid. All of these things are valid. I hope you are getting my point. So this is how you calculate. This is how you calculate. This is how you calculate what? This is how you calculate. This is how you calculate the determinant of a n cross a n body. Now, till now you understood what do you mean by determinant. What is 1 cross n, 1 cross 1 determinant, 2 cross 2 determinant, 3 cross 3 determinant, 4 cross 4 determinant, or any n cross n determinant. Then how you calculate cofactor for each position in a determinant, and how you calculate the value of entire determinant. All these things you are clear about. Okay. Hello, I think that it's valid. It's working now. Hello, hello. Yeah, better. We'll extend this session by 6-7 minutes because they are wasted. Okay, anything, anyway. Ha. Okay, let us calculate a very simple thing, a determinant. Let us start with calculating a determinant of a 4 by 4 matrix so that everything will be clear to you. 0, 1, 2, 3. 0, 1, 2, 3. 1, 0, 3, 0. 1, 0, 3, 0. 2, 3, 0, 1. 2, 3, 0, 1 plus 3, 0, 1, 2. 3, 0, 1, 2. Okay, sir, you have told us that we can calculate determinant by using any row or any column. Yes, my friend, I have already told you about that. So, sir, we will select the second row. I'll ask you why you will select the second row. And some really intelligent of you will answer, sir, we need to multiply the number with the cofactor. In the second row, there are two numbers as 0. So our calculation will become simpler because we will multiply with anything with 0 will become 0. So we'll start with 1 into cofactor of 2 comma 1 plus 3 into cofactor of 2 comma 3 plus 0 into cofactor of this position will be 0 plus 0 into cofactor of that position will be 0. 1 into cofactor of C21 will be 2 plus 1 into cofactor of this position will be what? This row and this column will go. You will be left with 1, 2, 3, 1, 2, 3, 3, 0, 1 and 0, 1, 2. Okay, sir. Absolutely clear. Plus 3 into minus 1 to the power 2 plus 3, that is for cofactor for 2 comma 3, and then determinant, that is we are calculating cofactor for this. So this row and this column will be eliminated. You will be left with 0, 1, 3, 0, 1, 3, 2, 3, 1, 3, 0, 2. Sir, we know how to calculate it. Now we know how to calculate it. We'll move further. 1 into minus 1 because this value will be minus 1 to the power 2 plus 1. So this will be minus 1. And we are now expanding it along the third row because there is one more 0. So what will be the value of determinant here? 0 minus 1. This position cofactor will be 1 into minus 1. Okay. Into 1 into 1 minus 3 into 3. That is 1 minus 9 plus 2, that is positive position. See, after some time now you will start understanding. You will not be writing this minus 1 because you know this is a plus position, this is a minus, this is a plus position, this is a minus. Okay, so accordingly we know that this is a plus position, this is a minus, this is a plus position. So 2 into, how you calculate the cofactor of this? 2 into plus 1 into 1 into 0 minus 3 into 2, that is minus 6. Okay, so this will be equal to what? Minus 8, that is plus 8 minus 12. So this will be minus 4. This will be minus 4. Okay, and what will be the value of this term? 3 into minus 1 because this will be a negative term into, we'll expand along the first row itself because there is a 0. So 0 minus 1 into minus this position 1 into this row and this column will go 2 into 2, 4 minus 3 plus this position, that is 3 into 2 into 0 minus 9, 0 minus 9. this will be equal to what? 3 into minus 1 minus 27. Okay, minus 1 minus 27, right? Minus 1 into minus 27. So this will be what? And minus sign is already there. Minus sign is already there. So this will be minus 28 into 3, 28, 60, 84. This will be minus 84. This is minus 84. So, okay, minus 84. So here you will have minus 4 minus 84. And the answer comes out to be minus 88. This is the determinant. Now the determinant for this 4 by 4 matrix is minus 88. How you have calculated it? I have already told you. See, you will not be asked to calculate determinant in the final exam, or if it is asked, you don't have to solve so many steps, because they don't want you to do labor. They want you to use your brain, and where brain is used in determinant? In its properties. So let us now directly move to property. We'll move to property, and there are 12 properties of determinant that you need to understand. Properties of determinant. Properties of determinant. Now, very important thing. Now, first property, if any row or column is 0, then determinant is also equal to 0. Why? Obviously, sir, if any row or column is 0, determinant will be 0. It is not, you can say, it is not a very big thing. Obviously, if the entire row or column is 0, everything will be multiplied by 0, so determinant will be 0. Okay. Second, very important thing. If rows and columns are interchanged, determinant does not change. Determinant remains same. You can test it. You can test it. If you change the rows or column, the determinant will not be changed. See, I'm not talking about one row or column. If you change the second row into second column, like all rows into all column, okay, so please note it down. A determinant remains unaltered by changing its rows into column and column into rows. Okay. Third and very important property. Third and very important property. If any, please be careful, two rows or column are interchanged. If any two row or column are interchanged, then determinant retains numerical value but changes its sign. For example, 1 2 3 4 5 6 7 8 9. Suppose the determinant of this is k. Now I am asking you, what is the determinant of 2 5 8 1 4 7 3 6 9? What is the determinant of this? Sir, you have interchanged two column. So as you told in the above property, the numerical value will remain same, just the sign will change. And that is why now again, if you interchange two rows or column, again the sign will change. Again it will become plus k. So please be careful. This is a very important property, and that is why, see, in examination you will be given this and you will be asked this. Now you will act like a fool if you actually start calculating the value of this determinant, because you are not supposed to calculate it. You are supposed to apply this property that if it is k, then the second thing will be minus k when you interchange any two rows or any two column. Now again, if you change any two row or any two column, again the property will occur and this will again become plus k. Okay, this is an important property. Now understand. Fourth, if any two rows or columns are identical, then determinant becomes 0. Very, very important. That is, if two rows are same or two column are same, the determinant becomes 0. You can take any value and you can justify the thing. I am not going to justify. Okay. Now, please be careful. Fifth property, and a very important property. This is a very, very important property, and this is a star marked property because this property is different, entirely different in your matrix. I'll tell you how. If any row slash column is multiplied by a scalar quantity, then whole determinant is multiplied is equal to then determinant is equal to scalar into old determinant. Okay, I'll tell you what do you mean by this. See, A, B, C, D, E, F, G, H, I. Suppose the determinant of this is Z. Now, what will be the determinant of 2A, 2B, 2C? I have changed the value to 2 to 2. Then the whole determinant will be changed by 2. Okay. Now, this is very important. If 2 is multiplied to all the numbers, then determinant will be changed by 2Z. Sir, how is it even possible? Just by changing one row, the determinant is getting changed. So for every row, you will multiply a 2. Okay, this will be, that is 8Z, because we are taking 2 out from every row. So this is a very important property. If you multiply any scalar quantity to all the values, then the determinant will not be multiplied by that value. Okay, because for every row it will be multiplied, every row and every column it will be multiplied by that value. Okay, so for any row and any column, if you are taking out a scalar or like impinging a scalar, it will be very simple thing. I will again explain you. This is a very important thing. KA, KB, KC, D, E, F, G, H, I. Okay, now if you take out K, it will be like this: A, B, C, D, E, F, G, H, I. Okay, very simple thing. Okay, very simple thing. Okay, very simple thing. From any one row or any one column, you can take out a scalar quantity and multiply that with the determinant. See, many people think and many people understand it as like this. That is KA, KB, KC, KD, KE, KF, KG, KH, KI. So what will be the determinant, beta? What will be the determinant in this case? Sir, we'll take out K and determinant will be A, B, C, D, E, F, G, H, I. Right? This is what I have taught you? No. Sir, in one case you are saying that I am taking out K from any one row. Okay, any one row. So in this case, if you are taking out K, so you will take out K from each row. from each row. Okay, so there will be 3 Ks outside. There will be 3 Ks outside. There will not be 1 K. There will be 3 Ks outside. Whereas in matrix, there is only 1 K. So in determinant, if you are multiplying it with scalar, you will be multiplying any one row or any one column. And if you are taking out, please be careful that you apply this rule. That is, you don't have to take out, if you are removing all the K, you are taking the K common from all the values. Then you have to multiply K cube outside, not K. Because for every row, you have taken out a K. Or for every column, you have taken out a K. Very, very important property. Very important property. Very important thing. Yeah. Now, please write another property, fifth, na? So this is a sixth property now. This is a sixth property. Suppose the determinant is like A, B, C, D, E, F, G, H, I plus M plus N plus L. Suppose this is the determinant. Now this determinant can be broken down into two parts. One is A, B, C, D, E, F, G, H, I plus A, B, M, D, E, N, G, H, L. Okay. So determinant can be broken down into this part. Determinants can be broken down into this part. The determinant can be broken down into this part. Okay, this is an important feature. This is an important feature. This is an important feature. Yeah, this is a very, very important feature. Please note it down. Please note it down. Now, let us solve a question. Let us solve a question for a better understanding. If A, B, C, A square, B square, C square, A, B, C, A square, B square, C square, and A cube minus 1, B cube minus 1, A cube minus 1, B cube minus 1, C cube minus 1. Determinant of this is 0. Then ABC is equal to, multiplication of ABC is equal to what? This is your question. Sir, first of all, we'll break it into two determinants. A square, A cube, B square, B cube, C square, C cube. And sir, second one is minus A square 1, B square 1, C square 1. Right? This is the scenario. This is the scenario, or what? This is equal to 0. Yes, sir. Absolutely agreed. We have broken it into two parts. See, plus. It's like this. You have taken out a minus sign from the third column and you have wrote it here. That's it. Okay. So now here, please be attentive. You take out A from here, B from here, C from here. A, B, C. This can be written as 1, 1, 1. A, B, C. Because A, if you take out A from first row, 1, A square. Minus A, B, C, A square, B square, C square, 1, 1, 1. This is equal to 0. Sir, this seems like same thing. Now, you just need to solve it up. You just need to solve it up. Sir, what we can do? You exchange these two rows. And then you exchange first row and third row. Okay. So if you change these two rows, I'll explain it here. If you change these two rows, what will be the determinant? Minus sign will come in forward. That is A square, B square, C square, A, B, C, 1, 1, 1. And now you are changing these two rows. Again a minus sign will come, so it becomes plus because already there was a minus sign. Now this will come 1, 1, 1, A, B, C, A square, B square, C square, right? So these two things will become same. These two things will become same. And now we can write it as A, B, C minus 1 and determinant 1, 1, 1, A, B, C, A square, B square, C square, and this is equal to 0. Now this has to be equal to 0 because it's in multiplication. ABC minus 1 is equal to 0, or ABC comes out to be equal to 1. ABC comes out to be equal to 1. So this is how you solve a question. This is how you solve a question of determinant. Let us solve one more question. Let us solve a question. This is a big question. See, why I am making you solve big question, there is a specific reason for that. See, you have to understand in GATE examination you are going to get very easy question, but the conceptual learning that you will be having in these sessions will come from a difficult question. So till now we have seen almost like very important properties of determinant. Factor theorem, okay, I'll check that any property. Multiplication of determinant is very important now. I'll make you solve. Now see, the more you solve different question, the more you will be thorough with the properties, and once you are thorough with the properties you can solve any GATE questions like this. For example, let us start with another question. Let us start with another question. One plus A, 1, 1, 1. 1 plus A, 1, 1, 1. 1, 1 plus B, 1, 1. 1, 1, 1 plus C, 1. And 1, 1, 1, 1 plus D. Okay, 1 plus D. You have to calculate the value of this. K 1 plus 1 upon A plus 1 upon B plus 1 upon C plus 1 upon D. You have to calculate the value of K, that is find K. Find K. This is your question. Okay, sir. We'll start solving it. We'll start solving it. So first, when you will try to solve it, try. See, it depends. You will be getting different kind of questions. Ultimately, the important part is you have to click that thing that, see, you are having A, B, C, D in inverse. So why not take out A common, B common, C common and D common, so that we'll be having a value of inverse. Let us check. See, there is no one format to solve a question. I am seeing from final part that you are having the values as 1 by A, 1 by B, 1 by C, 1 by D. So why not convert this whole thing into inverse first, because then only we'll be getting the values in solution as inverse na. So let us check. So we have taken out A, B, C, D common. A inverse plus 1. 1 by A or A inverse plus A common 1. A inverse, A inverse, A inverse. A inverse, A inverse, A inverse. B inverse, B inverse plus 1, B inverse, B inverse. C inverse, C inverse, C inverse plus 1, C inverse. D inverse, D inverse, D inverse, D inverse plus 1. Okay, so this is our determinant. Yes, sir. This is our determinant. Separate it. We can separate it. We can first of all separate it. This is not a very big thing. Now, what we can do? We'll separate it. So one will become A inverse, A inverse, A inverse, inverse, B inverse, B inverse, B inverse, B inverse. That will be equal to 0. So we can replace it as plus 1, only plus 1, only plus 1, and only plus 1. Many of you will ask why, sir? I have already told you that whenever you are having in addition some values, you can separate to matrix. Now when you separate to matrix, the first matrix will become 0 because it will be having A inverse, A inverse, A inverse, inverse. The second matrix is plus 1 A inverse, A inverse, A inverse, B inverse, plus 1 B inverse, B inverse, C inverse, C inverse, plus inverse, C inverse, and D inverse, D inverse, D inverse, and 1. Okay, now this is the matrix that you are having. Okay, sir, fine. Now how will you proceed? Now how will you proceed? You can directly calculate the value as well. The answer will come out as, because this value will come out to be 1 upon A plus 1 upon B plus 1 upon C plus 1 upon D. And outside you are having ABCD. So ultimately the value of K is ABCD. But now you will ask, sir, how you have written this from this? See, the thing is, when you will solve now, you will get this thing because the calculations are quite lengthy. The calculations are quite lengthy. That's why I'm not getting into it. That's why I'm not getting into it. Okay. Now, one very important property I will tell you. Very important property. Right. Row and column. Right. Row and column. If to each element of a line, if to each element of a line, this is property number 7. This is one of the very, very important properties. If, this is a very important property. If to each element a line be, if to each element a line be added to which, if a line be, please note it down, then I'll explain you. If to which a line be added equi-multiple of corresponding elements, equi-multiples of corresponding elements of one or more parallel lines, the determinants remain unchanged. The determinant remains unchanged. Now this is again a very important property, and this, you are going to use this property in your matrix and I don't know where all, because this is the most important property. This is the most important property. A, D, F, G, H, I. Suppose the determinant is K. Now, let me number them. This is R1, that is row 1, row 2, 3, column 1, column 2, column 3. If I write row 1 tends to row 1 plus any multiple you are taking, P times of row 2 minus Q times of row 3. Suppose you have taken this. Now you are changing row 1 into something which is having row 1, row 2, row 3 and some multiples. Okay, so now the row 1 is changed. That is, row 1 is equal to row 1 minus P times of row 2 plus P times of row 2 minus Q times of row 3, that is QG. Okay, row 1 is equal to row 1 plus p times of row 2 minus q times of row 3. So row 1 is equal to row 1 plus q times of row 2 minus q times of row 3. Okay, row 1, the second element would be, first element would be a plus pd minus q. Second, row 1 tends to row 1 plus p times of row 2 minus q times of row 3. Row 1 tends to row 1 plus p times of row 2, that is pf, minus q times of row 3, that is qi. Any other row is changed? No. def g h I. What will be the determinant of this? Sir, the determinant will be again k only. Why? Because you are operating a row by adding or subtracting multiple of, by adding or subtracting multiple of other rows. Or same thing you can do with column. If you are adding multiple of, like adding or subtracting multiple of other rows to any row or any other column to any column, the determinant remains unchanged. The determinant remains unchanged. And the basic question for this is very simple thing. I'll tell you. Very simple thing. Now, how you will use this property? 2117, 2117, 7 and 10. 7 and 10. 24, 22, 6, 10. 24, 22, 6 and 10. 6, 8, 2, 3. 6, 8, 2, 3. 6, 7, 1, 2. 6, 7, 1, 2. You have to calculate the determinant of this. See, if you go by normal method, that is 21 then into cofactor of this position plus 17 into cofactor of this position plus 7 into cofactor of this position plus 10 into cofactor of this position, it will be a very long process. Sir, why not use a property to solve this question? Why not use a property to solve this question? Sir, I think how you can use it? Can use it, that's not a, see, this is a question. Now I'll tell you how they have used it in the booklets. Okay, how they have used it in the booklet. Okay, so that, see, this is a question, okay, that I have noted down from a standard book. Now, see, now it is very difficult to identify that how to solve this question using properties. But I'll tell you that how they have solved it. Now, if the question is simpler, now you will be able to solve it. I'll tell you how. I'll tell you how. For example, I'll take another question for you. I'll take another question for you. Please be attentive. 1, 2, 3. 3, 8, 6, 9. Sir, what is the determinant of this? What is the determinant of this? Sir, what is the determinant of this? Can you write column 3 is equal to column 3 minus column 1 minus column 2? Can you write it like this? Sir, simple na. So this determinant can be written at like this. First column, no change. 1, 2, 3, 4, 6. Now, third column is third column minus first column and second column. So 3 minus 2 minus 1 is 0. 6 minus 4 minus 2 is 0. And 9 minus 6 minus 3 is 0. So if these three terms are 0, the whole value of determinant will become 0. Okay. How? By applying just a small formula, I have converted one complete column into 0. Okay. And now from another property, I know that if all the three values of any row or any column is 0, then the value of determinant of that matrix, determinant of that like matrix is always 0. Okay, so how I have done it? By column transformation. So these operations are known as transformation, row transformation and column transformation. I am transforming a column into another value. Okay, but the determinant remains unchanged because this is a property of determinant that if any column gets changed by adding or subtracting another columns or the multiple of the other columns, then the determinant remains unchanged. That's what I have made you write. Okay, that's what I have made you write. Is it clear? So this is an easy question. This is not a difficult question. This is a quite easy question. And if you go back to this problem, this problem again, we'll try to solve. Now I will try to solve. I'll tell you how to solve. This is 1. Okay. B inverse 1, B inverse, B inverse. Okay. Now, what we can do? This is A inverse plus 1, na? Keep it like this. B inverse plus 1, C inverse plus 1 and D inverse plus 1. Okay. Now what you can do? You can add all the rows. Can I write it like this? R4 tends to R1 plus R2 plus R3 plus R4. So it will be 1 plus A inverse plus B inverse plus C inverse plus D inverse. In all, like all the 4 values of R4 will be this only. Okay. So how you will go about it? This is a very simple thing. Understand. Now I am saying R4 tends to R1 plus R2 plus R3 plus R4. Now how R4 will change? 1 plus A inverse plus B inverse plus C inverse plus D inverse. D inverse will be replaced by this whole value. Similarly, here D inverse will be replaced by the sum of all these values. Similarly, D inverse here will be replaced by all the values. Similarly, D inverse plus 1 here will be replaced by all the values, summation of all the values. And now if you take out all the value, 1, 1, 1, 1. 1 plus A inverse plus B inverse plus C inverse plus D inverse. Okay. Now this is very easy to solve. Now this is very easy to solve. Now this is a matrix where 1, 1, 1, 1 is there. Simple, very simple thing. Now what you can do? You subtract column 1 tends to column 1 minus column 2. Okay. Yeah, or you can write column 2 tends to column 2 minus column 1. Column 3 tends to column 3 minus column 1 plus column 4 tends to, and column 4 tends to column 4 minus column 1. So all the 4 columns are subtracting all these columns are subtracting the first column from itself. So the lower value will become 1 minus 1 0, 1 minus 1 0, 1 minus 1 0. You will be only left with 1 here and all the values here. Very simple thing. And then you will realize all these value will sum up to. So that is why the answer will be K is equal to A plus B, A, B, C, D. Now this might looks very tough to you, but I think that I have to rush because since this is a gate lecture and I have to finish it up in a given amount of time. But yes, we'll solve more questions from determinant in the last lecture where we will be solving questions. So I'll take 1 or 2 lectures, complete 1.5 hour lectures to solve problems from this topic. Okay. So I think that determinant is almost complete. You know how to calculate determinant. You know what do you mean by determinant, and everything there is crystal clear to you. From the next lecture we'll be starting with matrix. Then we'll learn how to find out in the first session of matrix, general discussion on matrix and the property of matrix will be there. In the second session you will learn how to calculate the inverse of a matrix. In the third session of matrix you will learn how to calculate the rank of a matrix. Fourth session you will learn how to calculate the higher power and the Cayley-Hamilton theorem of matrix. And then lecture 5 will be the practice set on, or the previous year question set on matrix and determinant. And then I will take one more session, or in the previous year question session only, I'll take a very special category of session questions that belongs to linear transformation. So we have to solve questions from linear transformation as well, that whether all of them are collinear or not, or these type of problems. But believe me, after these sessions you will be able to solve each and every question from determinant and matrix. Okay. And now the thing is, I'll tell you, see, determinant problems are quite long. Okay. What I can do, either I can sip these problems and directly make you solve easy problems that are asked in the gate examination, but I don't believe that you will learn in that way. Okay. Whatever I have taught you today, you will be able to learn in that manner very easily. And yes, that's it. Okay, that's it. Thank you and all the best. Let us discuss more problems in the next session and start with the matrix. Thank you. Thank you guys. Thank you and all the best.